Welcome to the second lecture on Sustainability, Ethics and Technology. This is the second lecture in a series of 2 lectures. My name is Behnam Tayebi and I'm with a group of philosophy. Before we start this lecture, I would like to invite you to take a moment and think about the following questions. Which one of the following energy systems would you refer to as sustainable? Biofuel, wind energy, solar energy, nuclear energy, or fossil fuel? Think about this question, and I will come back to this question in the end of today's presentation. In today's talk, I will focus on the following subjects. Firstly, I will discuss the relevance of sustainability in discussions on energy. My argument would be that rather than an adjective, sustainability should be seen as a framework, an ethical framework, in which we at least answer 3 main questions. Sustaining what? Why should we sustain it? And for whom should we sustain it? On these issues I will focus in today's talk. Sustainability is a very relevant notion in the energy discussions for the following reasons. Recall that there are 2 dimensions of sustainability. There is social justice in a spatial sense, which means in the space dimension, and there is social justice in the temporal sense, or the time dimension. We have discussed in the first lecture the tragedy of the commons as the things that we hold in common with people in the future. The things that we hold in common are the non-renewable resources and the environment and the atmosphere. So these issues are all relevant when it comes to the energy discussions. Before we could discuss sustainability and address whether an energy system is sustainable, we need to actually first be very clear on the definition of sustainability. So how do we interpret sustainability and how do we cope with the conflicting interests? Because different interests might not be able to be accomplished simultaneously. And this both relates to the spatial and the temporal sense. My argument is that we should consider sustainability as a moral value from which we could derive other underlying values. In doing so, we would be able to address the interests of different generations and the possible conflicts that might arise from that analysis. So let me first focus on the question of sustaining what? Sustaining the environment and humankind's safety would be one interpretation of sustainability. So leaving the nature no worse than we found it, discussions of environmental friendliness, and protecting public health and safety. That would be one definition of sustainability, and another one would be sustaining human well-being, which could relate to resource durability or the availability of non-renewable resources. There is also the issue of economic durability. Let us review these notions for a second. You see here the 2 definitions that I just presented to you. On the right side is the sustaining the environment and humankind's safety. There are at least 3 values that we could derive from this: the value of environmental friendliness, the value of public health and safety, and security. It is important to note that in discussions on nuclear energy, we do make a distinction between safety and security. Safety relates to unintentional harm, while security relates to intentional harm. On the left side here, you see the 3 notions of resource durability relating to the availability of non-renewable resources, economic viability, to what extent could we continue an activity in the economic sense, and very important, especially for you as engineers, is the notion of technological applicability. How can current technology and future technology help us accomplish these values? And it is important to notice that once you design for the improvement of one of these values, other values might change accordingly. Let us review the just mentioned values for a moment. First of all, sustaining the environment. The very first question would be, why should we sustain the environment? We make a distinction here between 2 schools of thinking. That would be the school of anthropocentrism and non-anthropocentrism. The school of anthropocentrism would argue that the environment does not have an intrinsic value because it would only serve human beings. So it has an instrumental value insofar as itself human beings. Non-anthropocentrism, on the other hand, would argue that an environment has a value as such, that we call an intrinsic value. So, since it would be unreasonable to expect any change in the environment, the question that drives here is how can we repair or compensate for the inevitable change that will bring about? This question is very interesting and important to be addressed when it comes to the climate change discussion and, for instance, questions of toxic waste. The next issue would be sustaining health and safety. A very straightforward definition would be that we should not jeopardize the safety of people in the future. The question that drives here is how far in the future should we offer such protection? And is it feasible? Is it desirable that we offer exactly the same level of protection? And is it legitimate that we make a distinction between different people in the future? The relevance of the last question goes far beyond philosophical contemplations. Let me show you an example. Here you see the Yucca Mountain Repository in the state of Nevada. This is where Americans built for decades the world's biggest repository for nuclear waste disposal. Even though President Obama stopped further development because of the local oppositions in the state of Nevada, it is interesting to see how the national legislations have been formulated for this repository. The Environmental Protection Agency in the US proposes that the same level of protection should be offered for the next 10,000 years, while a much lower level of protection is acceptable for people who live beyond 10,000 years. So the current level of protection should be offered for the next 10,000 years. That would be 15 millirem. Millirem is a unit for radiotoxicity that Americans use. In Europe, we use the SI unit, sievert. And beyond 10,000 years, a level that is much larger and much bigger is also acceptable. So the question would be, is it acceptable that we offer people living further in the future a much lower level of radiological protection? So far we discussed the right side of the figure you just saw, sustaining the environment and public health and safety. Let's move to the left side. That would be sustaining well-being. The first issue, and perhaps the most important issue, would be sustaining the natural resources. Sustainability is here then interpreted as durability. Obviously, we can't stop using non-renewable resources, so the question that we should answer here is, to what extent may we use those resources, and how could we provide a kind of compensations for the non-renewable resources that we use and to which people in the future would not have access. There is an interesting debate going on the moral relevance of status quo. Status quo meaning continuing the current state. The status quo is fairly conservative if we take into account that we would pass on the same amount of resources while the world population is growing. Yet, the question that we need to answer is, to what extent is it the responsibility of the current generation to take into account future population growth? The last important issue would be economic durability. For an energy source to be sustainable, it must be economically durable, which means that we should be able to sustain its continuation for a period of time. The question that we need to answer here is durable for whom exactly? Because the first question would be whose interest is at stake and whose interests are we taking into account and for what period? Are we going to take into account future interest as important as the current interest? Or are we going to discount future interest as economists propose to do? Discounting is a very relevant and important notion when it comes to short-term policy making, but it becomes very problematic when it comes to the issue of, for instance, nuclear waste disposal and very long-term protection. In conclusion, in today's lecture, I presented two aspects of sustainability that are relevant in energy discussions. Firstly, the availability of non-renewable resources and the extent to which we may use those resources. And secondly, the question of how we affect the environment and public health and safety. Both these aspects have a temporal and a spatial dimension. Sustainability could be a very useful notion if we manage to first identify whose interest is at stake and if we manage to address the conflict of interest properly. Note that in properly, I'm referring to an ethical reflection on this notion. What are the conflicts of interest, and how could we, ethically speaking, come out of these conflicts? In the beginning of the lecture, I asked you to think about the following energy systems, with a question which one you deem to be sustainable. I hope your answer would be all of them and none of them at the same time. Because depending on the definition you follow, a type of energy system could be sustainable in one sense and very unsustainable in another sense. Take nuclear energy, which could be sustainable if you take into account that we could continue the usage of nuclear resources for a very long time using new nuclear technology. But it is very unsustainable when we talk about public health and safety and the issue of nuclear waste disposal. So what I hope to have discussed with you today, and I hope to have convinced you that there is no such thing as sustainable energy. Sustainability should rather be seen as an ethical framework with which we could assess different aspects of energy systems and start a discussion and a reflection on those energy systems. Thank you for your attention.